Good morning, students. We already discussed standard equation of a hyperbola. See the equation x squared by a squared minus y squared by b squared equal to 1. In the previous class, we derived the standard equation of the hyperbola from the basic definition of conics fp by pm equal to e. Here, what is the meaning of f? F is the focus. L is the directrix. E greater than 1 is the eccentricity of the hyperbola. So, by the diagrammatic explanation, already we discussed in the previous class. See the coordinate axis, x-axis, y-axis, origin. Here, L is the directrix. L is the directrix. See, Fp by Pm equal to E. That is the basic concept. See here F. This is A. This is Z. Already we discussed all the logics. Here F is the focus. It is denoted by AE, 0. A is vertex. It is denoted by A, 0. Z is a point on the directrix. Then Z is denoted by AE, 0. Then we already discussed P is a point. That means P of x, y is any point on the hyperbola. Now join Fp, then draw Pm. So M is that means Pm is the perpendicular from P to the directrix L. Now the point M is denoted by A by E, here y is unknown. So this is the logic we discussed in the previous video. So F focus we already derived AE, 0. Then Z, it passing to the directrix passing through the point Z. The value is A by E, 0. Then P is any point on the hyperbola. Then join Fp, then Pm. After that we worked out Fp by Pm equal to E. Then Fp equal to E into Pm. Then what is the meaning of Fp? Here it is nothing but the distance between 2 points. Pm is also the distance between 2 points. Then we worked out the equation x squared by a squared minus y squared by b squared equal to 1. Yesterday itself we derived the equation. Here the value of b squared equal to, listen here, a squared of e squared minus 1. See this. When compared with ellipse, in ellipse b squared equal to a squared of 1 minus e squared. Here e squared minus 1. The reason is here e greater than 1. The value of e greater than 1. So this is the standard equation of the hyperbola. Here we are giving the name b squared equal to a squared of e squared minus 1. Now listen, we are going to draw the diagram now. That means it is nothing but tracing the hyperbola. We already worked out the same concept in tracing the parabola, tracing the ellipse. Tracing is nothing but analyzing the diagram. After that we are going to draw the diagram, original diagram of the hyperbola. Here it is nothing but the theoretical explanation from the conics Fp by Pm equal to E. By using this, we are drawing this one. Now we are going to take out the clear diagram. See, the heading is tracing the hyperbola, x squared by a squared minus y squared by b squared equal to 1. Now we are going to tracing this hyperbola, x squared by a squared minus y squared by b squared equal to 1. Tracing is nothing but analyzing. We are going to analyzing this hyperbola. See this. It is even degree in both x and y. That is the first concept. Even degree in both x and y. See here, even power. Here also even power. Therefore, even degree in both x and y. Therefore, it is symmetrical about both axes See the standard equation of ellipse comparing with this one. There x squared by a squared plus y squared by b squared equal to 1. That is standard equation of ellipse. Here we are having only one difference, negative. X squared by a squared minus y squared by b squared equal to 1. When compared with the ellipse, here we are having a change. Then comparing with the ellipse, there b squared equal to here. For hyperbola, b squared equal to, for hyperbola b squared equal to a squared of e squared minus 1. For an ellipse, b squared equal to a squared of 1 minus e squared. These are the two changes so far. Now diagrammatically, we are having some changes. Even degree in both x and y, it is symmetrical about both axes. That is the first concept we are learning from this equation. Now, number 2. It is even degree in both x and y. Therefore, we are saying symmetrical about x-axis. Now, if it cuts x-axis, if it cuts, the second point, if it cuts x-axis, then substitute y equal to 0. Now, what is the standard equation? X squared by a squared minus y squared by b squared equal to 1. This is the standard equation. Now here substitute y equal to 0. Then what will happen here? If y equal to 0, the remaining is x squared by a squared equal to 1. Here y becomes 0. X squared by a squared equal to 1. Just I am cross multiplying this one. I can get x squared equal to a squared. From this, x equal to plus or minus a. Therefore, the point of intersection with the x-axis is, point of intersection with the x-axis is a comma 0 minus a comma 0. Compare with the ellipse. There also ellipse cuts the x-axis at two places. One is a comma 0, another is minus a comma 0. Here also the hyperbola cuts x-axis at two places. One a comma 0, another one is minus a comma 0. Just to substitute y equal to 0, we are able to get x equal to plus or minus a. From this we are concluding this a comma 0. See this a comma 0. Another one side we are going to draw the diagram. We are able to see minus a comma 0. Now this is the concept number 2. Then see the third point. If it cuts y-axis instead of x-axis, now I am replacing, say the word y-axis. Then substitute x equal to 0. See this explanation. I am substituting x equal to 0. If I am substituting x equal to 0 here, what is the remaining? See here, this value becomes 0. The remaining is minus y squared by b squared equal to 1. So from this I can write minus y squared equal to b squared. So say like this, y squared equal to minus b. Therefore, y is imaginary. Y is imaginary. See here y squared equal to minus b squared. Now y is imaginary. So the hyperbola does not cut y-axis. It never meets y-axis. That means if it cuts y-axis, substitute x equal to 0. Here x equal to 0 means minus y squared by b squared equal to 1. From that we can say minus y squared equal to b squared. Again y squared equal to minus b squared. Y is imaginary. Therefore, it does not cut y-axis. It does not cut y-axis. So, but ellipse cut both axes. It meets both the axes at a comma 0. Another one is minus a comma 0. Then 0 comma b, 0 comma minus b. So here hyperbola will not cut y-axis. And also another one concept. Hyperbola does not passing through the origin also. It does not passing through the origin. See here origin. So here a comma 0, another one side minus a comma 0 we are going to draw. So it passing through at a comma 0 and minus a comma 0 only. So hyperbola does not passing through the origin 0 comma 0 also. Now see here, this is the point a comma 0. Now I am going to draw the diagram of the hyperbola. Take down like this. This is the one side. We are having another side also. This is L. In the same side, other side we have L dash, although in the same way. Here see, it is Z. Because of the symmetry, we have another one Z dash. Here see, A by E comma 0. In the negative side, we are having minus A by E comma 0. Then see here A. Another one side we have A dash. See here F. Here also having F dash. So here A is A comma 0. A dash is minus A comma 0. Just now I am giving the explanation. Hyperbola passes through the 2 points A comma 0. Another one is minus A comma 0. Now take down the another portion here. So now F dash is minus AE comma 0. See the diagrammatic explanation. This is origin. Another one side L, here L dash. Here A dash. Then F dash. Compare with the ellipse. All the concepts are same only. In ellipse also FAE comma 0, that is called focus. Here also called focus. A comma 0, A dash minus A comma 0. This is called vertices. When comparing with the ellipse, that is also same only. Say L and L dash. This is called directrix. Another one side L dash. See A by E comma 0. Here minus A by E comma 0. And comparing with the ellipse, this is also the same one. So, but the results are same. But see the diagrammatic explanation. But when comparing with the ellipse already we discussed, it is a closed curve. Just see here, ellipse may be like this. We already worked out. See, ellipse is like this. It is a closed curve. But see here, hyperbola is a open curve. So ellipse from A to A dash, it is finishing. Starting from minus A dash, then finishing is A. But here, hyperbola is starts from here, then up to infinite. Here also up to infinite. Therefore, for the values of x, this is another concept, hyperbola exists for, see, x value greater than or equal to A. See, starting from this up to infinite it is. And for the value x, see here, less than or equal to minus A. This is the one important concept. Hyperbola exists for x greater than or equal to A, starting from here up to infinite. Here see, from minus A to up to infinite side. Therefore, if x tends to infinite, after this, if x tends to infinite, y also tends to plus or minus infinite. That means the curve branches out to infinite. Up to infinite side it is moving. Here also moving. But in between, ellipse is placed. This is the ellipse. This is the hyperbolic diagram. So see the concept. F, A, Z. Because of symmetry, we are already having an explanation. Because of symmetry, L dash is called second directrix. F dash is called second focus because of symmetry. We are already well known the meaning symmetry. Symmetry means identical. See the diagram here, LHS side, here other side RHS side, the same diagram. Therefore, it is symmetrical. So A to up to infinite. See, after this we are able to work out any number. Then y tends to infinite. Here also up to other side it is x dash. So negative side up to infinite. Therefore, this is the diagrammatic explanation. Here, because of symmetry, L dash is called second directrix. We are already, yesterday itself we worked out one directrix L. So now we are thinking about symmetrical diagram. So L dash is called second directrix, and see F dash minus AE comma 0 is called second focus. So this is the diagrammatic explanation. So L dash, here F dash. Already we discussed about A dash. What is the meaning of A dash? Already we discussed A and A dash are any 2 points on FZ which divides internally and externally. We already worked out in the theoretical concept. There itself we are discussing about the total length of A dash. A dash equal to 2A. We already discussed it. So A dash equal to 2A. C is the midpoint. Here already we discussed it. C is the midpoint of A dash. Therefore we are discussing CA equal to CA dash equal to small a. So that explanations are already we worked out. So this is the diagrammatic explanation. And just remove this elliptical portion. After that you can see the full diagrammatic explanation of the hyperbola. So we already discussed about standard equation of the parabola and the relate and then some results based on the parabola. Now we are discussing about hyperbola. See the word clearly. The first one is parabola. Now this is hyperbola. This is minus a comma 0. So A and A dash are the vertices. Now this is the full diagrammatic explanation of the hyperbola. So this. So it have a symmetrical diagram. Here we are having b squared equal to a squared of e squared minus 1. Now from this we are able to work out E value. What is the meaning of E? That is the eccentricity. For a parabola E equal to 1. For an ellipse E less than 1. Now see, we are able to work out E from this. Just listen. B squared, now I can write like this. B squared by A squared equal to E squared minus 1. Just take this negative to the same side. So we can write 1 plus B squared by A squared equal to E squared. Take LCM. Therefore I can write E squared equal to A squared plus B squared divided by A squared. Therefore E means eccentricity. I can say square root of A squared plus B squared divided by A squared. This is the eccentricity for hyperbola. But compare with the ellipse. What is the difference? For an ellipse, E value is A squared minus B squared divided by A squared. For an ellipse, here A squared plus B squared. Say the reason. A squared minus B squared means it will be less than 1. A squared plus B squared divided by A squared producing the value of E. That means greater than 1. Already we have the definition. For an ellipse, E less than 1. For a hyperbola, E greater than 1. This is derived from the standard result. This result already we explained in the first theoretical concept. But that means standard equation of hyperbola. So B squared equal to A squared, E squared minus 1. From that I can simplify this one. B squared by A squared equal to E squared minus 1. Take this negative, we can get positive. Then take LCM. From that E equal to square root of A squared plus B squared divided by A squared. This is the value of E. Now we are having some standard results now. We are having some standard results. What are the standard results now we are going to work out? See now. Y dash, x dash. Now this is the first type. We can say first type, type number 1. The name of this. Already we are having some types in your parabola and also in your ellipse. For the hyperbola, we are having 2 types. Type number 1 is, now listen carefully, take down the results. This is type number 1, x squared by A squared minus y squared by b squared equal to 1. See, the name of type number 1 is transverse axis. Transverse axis along x-axis. Along x-axis. You know the meaning of transverse. It is the x-axis. See the diagram. This is the hyperbolic diagram. This x-axis is passing through these A and A dash. This axis is called transverse axis. You may know this word transverse transverse. In your physics you are hearing this word transverse. So here transverse axis means this line, that is the penetrating line of this hyperbola. So this line is called transverse axis. So transverse axis C along x-axis. This is type number 1. Compare with the ellipse. There you are saying major axis. X squared by a squared plus y squared by b squared equal to 1, a greater than b. That is type number 1 is called major axis along x-axis. Here you are using the one word transverse axis. There you are mentioning major and minor. Here you are using transverse axis. This is type number 1. So x squared by a squared minus y squared by b squared equal to 1. This type is called, say, type 1. This type number 1, the name is transverse axis along x-axis. Now what are the results? The same results in compare with your ellipse. What is it? See the center. Center is 0, 0. In ellipse also you are using the same word, center. Then here see focus. F AE, 0, F dash minus AE, 0. That is also same. Then vertices A and A dash. See the value of A is A, 0 minus A, 0. There also in comparison with ellipse that is also same. Then L and L dash are called directrices. Its equation x equal to A by E. Here x equal to minus A by E. So we can say x equal to plus or minus A by E. All these results are same. So take down the results from the diagram. No need to memory. I am always insisting this word. No need to memory. Compare the result. Then you can say the technical name. See the naming here. What is that? Result number 1, center. Result number 1, center C 0, 0. Center C 0, 0. This is the point number 1. Then point number 2, foci. Foci. One focus AE, 0. Another focus is existing the other side, that is minus AE, 0. Then point number 3, vertices. Point number 3, vertices. What are the values? A of A, 0, then A dash of minus A, 0. These are the vertices. Then point number 4, equation of the directrices. Equation of the directrices x equal to plus or minus A by E. These 4 results are the same result as in your ellipse. Same only, center, foci, vertices, directrices. No change in these 4 results. Now listen, here E must be greater than 1. When compared with the ellipse, E is less than 1 in ellipse. Here E is greater than 1. Then the formula to find the E is, for an ellipse, E equal to square root of A squared minus B squared divided by A squared. This is for an ellipse. This is for an ellipse. But here the value of E equal to, just say only one symbol, A squared plus B squared divided by A squared. This is for hyperbola. This is for hyperbola. See the comparison. Then no need to memory. E value A squared minus B squared divided by A squared for an ellipse. Here A squared plus B squared, only one change. Then these 4 results are the same as comparison with ellipse, the 4 results. Now what are the changes here? See now, A dash equal to 2A. That is also in your ellipse also the same result only. A dash equal to 2A. See this one. This value A dash, we already say the result number 5. A dash equal to 2A. In ellipse also A dash equal to 2A. But the naming is here, it is called length of the transverse axis. This is called length of transverse axis. Length of transverse axis. But in your ellipse, what is the name of A dash equal to 2A? There you are saying length of the major. The word is major, minor in your ellipse. But here, length of transverse axis. Now what is the equation of transverse axis? Now that is result number 6. Equation of transverse axis. Equation of transverse axis. Here I am just now explaining x-axis is the transverse axis. What is the equation? Y equal to 0. Y equal to 0. See the compare the same result with your ellipse. There also a dash equal to 2a, but the name is in your ellipse length of major, for a hyperbola length of transverse. That is the only one word is changing. Then the equation of transverse axis is y equal to 0. There you are using equation of major axis. Instead of transverse, you are using major in ellipse. That is the only one change. But the results are same only. Then another one. See here. Result number 7. Here it will not cut y-axis, but for assume, see here, it is B. We are saying it is B dash, but it will not cut y-axis, the diagram. When compared with ellipse, B dash or the meeting place of y-axis of an ellipse. But here there is no meeting place, but we are taking assumed value. This B dash equal to 2B. The name is conjugate axis. Length of conjugate. Use here length of conjugate axis. But in your ellipse you are using the word length of minor. You are using the word length of conjugate. It is nothing but an assumed distance. B dash equal to 2B. Length of conjugate. Now what is the equation of now conjugate? Equation of conjugate axis. Equation of conjugate axis. What is the name equation of conjugate axis? See here, equation of conjugate axis. It is nothing but y-axis. The value is x equal to 0. Here the length of the conjugate axis. Here length. Here you are using equation. So length is B dash equal to 2B. But in your ellipse they are using the word length of minor. And the next one is equation of conjugate axis. Equation of conjugate axis is nothing but equation of y-axis. The value x equal to 0. So this is result number 7 and 8. Now another one, length of lattice rectum. You are using the same word in your parabola and also in your ellipse. Now the same length of lattice rectum. What is the result is 2b squared by a. The same value of an ellipse. So in your ellipse you are using the same length of the lattice rectum. What is the meaning of length of the lattice rectum? See here, a focal chord passing through the focal chord means it passing through the focus, which is perpendicular to the transverse axis. Just now we are going to derive. Just you take down length of the lattice rectum is 2b squared by a. The same result of ellipse. Then result number 10 is equation of lattice rectum. Equation of lattice rectum. See what is the meaning of lattice rectum? Just now I am explaining. It is a focal chord perpendicular to the transverse axis. That is called lattice rectum. See, that means it is passing through the focus. So as well as perpendicular to x-axis. Therefore its equation x equal to AE. In the same way we are having the another one side x equal to minus AE. Equation of lattice rectum is x equal to plus or minus AE. These two results are same as an ellipse also. Length of the lattice rectum 2b squared by a. Equation of the lattice rectum x equal to plus or minus AE. These are the two results already were worked on in our standard equation of an ellipse. The same one. Now we are going to work out how it happens. That is the next heading. Now take down the heading lattice rectum. Then already you are worked out lattice rectum of an ellipse. Here also you are going to work out lattice rectum for a hyperbola. But the result is same. See, the heading is lattice rectum. But you must know the definition. What is the definition? A focal chord which is perpendicular to the transverse axis of a hyperbola. See the word? But in your ellipse you are using major axis. You are using transverse axis. That is the only one change. It is a focal chord perpendicular to the transverse axis. Now see the diagrammatic explanation. See just now you take down the same diagram. So this is L dash. Say F here. This is called F. It must be A. This is the hyperbola diagram. Here Z. Here C center. Here Z dash. Then another side is A dash. This side is called A dash. Then this is called F dash. F dash, A dash, Z dash. So this is the hyperbolic diagram. Now what is the definition just now I am explaining? A focal chord, this is the focus. Focal chord perpendicular to the transverse axis. See this diagram? A chord passing through the focus is called focal chord. It is perpendicular to the x-axis. This is x-axis. X-axis is nothing but transverse axis. Now what is the name of the focus? Value of the focus is F A E, 0. Now this point is technically called L. This endpoint. This endpoint is called L dash. You know the value of L. X must be AE only. Then Y is unknown. Here also X must be AE. Y is unknown. But Y will be the negative value. So we can say first initially Y. Here Y must be positive. Here Y must be negative. That means L AE, Y. Here F AE, 0. Here L dash AE, so this is the diagrammatic explanation about the lattice rectum. Now see the definition. What is the meaning of lattice rectum? A focal chord which is perpendicular to the transverse axis. Transverse axis is nothing but x-axis. So this is the focal chord. It has two values. One is the length of the lattice rectum. Length means from this LL dash. Length is nothing but LL dash. The value is already we just now worked out 2b squared by A. Then equation. Now what is the equation? See this line passing through AE, 0. Therefore we here x value is AE. The same way, see here F dash. So this is F dash. Here also we are able to draw the same diagram because of the symmetrical. So this is L1. See this is L1 dash. This is also lattice rectum. It must passing through the point minus AE, 0. Minus AE, 0. Here we are able to work out now. Here it is L1, it is L1 dash. These are called endpoints. So see here x equal to AE. Here x equal to minus AE. Therefore equation of lattice rectum is x equal to plus or minus AE. Just now we take down the result. This is the positive side, this is the negative side, so we say x equal to plus or minus AE. This is the equation of lattice rectum. Now we are going to work out length of the lattice rectum. We need L and L dash. Then only we are able to work out the length. See now. See the explanation. This is the hyperbola. Now the hyperbola passing through L and L dash. See the explanation. This is hyperbola. We are taking one side L and L dash. Therefore we can substitute x equal to AEC. X value known, y value is unknown. Here also x value known. It's the same AE. Y value unknown. Now what is the equation of the hyperbola? X squared by A squared minus y squared by B squared equal to 1. This is the equation of the hyperbola. So this equation passing through the point. Therefore we can substitute x equal to AE. Now I can substitute x equal to AE. That is a known value. Y is unknown. So we are going to derive the value of y. So substitute x equal to AE. See, I am substituting x equal to ae the whole squared divided by a squared, then minus y squared by b squared equal to 1. Just squaring this value, we can get a squared e squared divided by a squared minus y squared by b squared equal to 1. Now a squared will be removed. So I can interchange these two values. See, this 1 comes here. This y value goes to the other side. Then what will happen here? See, e squared minus 1. 1 comes to this side. It will take negative. This negative goes to the other side. We can get positive y squared by b squared. Cross multiplying this b squared. Therefore, I can say y squared equal to b squared of e squared minus 1. So can you follow this result? This is the standard equation of the hyperbola. This hyperbola passing through the point L and L dash. Therefore, we can say x equal to ae. Substitute in this equation. This becomes ae the whole square. Therefore, I can say a squared e squared divided by a squared. A squared will be removed. Then interchanging these two. This y squared goes to the other side. 1 will come the other side. E squared minus 1 equal to y squared by b squared. Just cross multiplying, I can say y squared equal to b squared of e squared minus 1. Just now I am explaining what is the value of b squared. In the standard equation we derived what is the value of b squared. B squared equal to a squared of e squared minus 1. From that only we are deriving e value. So see here, I need this one. I can say b squared by a squared equal to e squared minus 1. So instead of this e squared minus 1, I am going to substitute y squared equal to b squared. This e squared minus 1 replaced by b squared by a squared. See this one, e squared value e squared minus 1 is replaced by b squared minus 1. Therefore, this e squared minus 1 replaced by b squared by a squared. Now, I want to find the value of y. See what is the meaning? I am going to take the square root. So, it will become, if you are taking square root, it will become plus or minus. Then here we are having b power 4. It will become b squared. Then here a squared will become a. This is the value of y. Y equal to plus or minus b squared by a. See this result? This is the standard equation of the hyperbola. It passing through the point L and L dash. What is the meaning of L and L dash? These 2 points are called endpoints of the lattice rectum. Then substitute x equal to ae. Then simplify. You are able to derive y squared equal to b squared of e squared minus 1. Then we are able to replace this e squared minus 1 with the help of this. We already worked out in your standard equation of the hyperbola. Then I can write b squared by a squared equal to e squared minus 1. Just to replace, we can get b squared by a squared. Then the value of y equal to plus or minus b squared by a. That means b power 4 is here. We are taking square root, you can get b squared. Here a. This is the value of y. See, just now I am explaining. This is the value of y. Take the positive result here because it lies in the first quadrant. Therefore, it must be b squared by a. It must be b squared by a. See here L dash. It must lies in the fourth quadrant. Here it will take the negative. Therefore, minus b squared by a. So this is called endpoints of the lattice rectum. Now listen. This is the theoretical concept of length of the lattice rectum. How we are working out. See, we need now L dash. That is called length. Length of lattice rectum. Length of lattice rectum. That is nothing but L dash. The value of L dash is here. See, F dash. We can say from FL it is already 0 here. The value. This is nothing but y value. What is the y value here? B squared by a. The y value is b squared a plus. See what is the value of y here? That is also b squared by a. But we are thinking about, see, the length. Length must be always positive. Point wise it is negative. Therefore, it is also b squared by a. Otherwise, you can use the distance formula also. So, L dash is nothing but the distance between 2 points. See, AE minus AE will goes. What is the formula? x1 minus x2 the whole square. y1 minus means already having minus. So, minus of minus it will become positive only. Therefore, I can say simple way. So, from this diagram, this is FL. What is the meaning of FL means? It is nothing but the value of y distance. See here b squared by a. Here also y distance. Take down the result. Don't take the positive. Length must be a positive unit only. So that is the logic. So b squared by a, b squared by a. So we can say 2b squared by a. This is the length of the lattice rectum. Just now we say the result. Already we worked out the result. But this is the theoretical explanation. So this is FL dash. So one more question may be asked like this. What is the length of the semi-lattice rectum? They are using only one simple extra word, semi-lattice rectum. Many students are writing 2b squared by a. So this is the length of the lattice rectum in LL dash. Semi means half of this. So FL dash. See b squared by a. Here also b squared by a. When you are comparing the points, you can use the symbol. Length must be always positive. B squared by a, that is also b squared by a. So FL dash is equal to b squared by a is called length of the semi-lattice rectum. So when comparing with the length, in your ellipse also the same result to b squared by a. Then this is called AE comma b squared by a. L dash AE comma minus b squared by a are called endpoints of the lattice rectum. This is also one more question. They may be asked like this. L and L dash are called endpoints of the lattice rectum. See here also we are having one more endpoints. See this one. Now I am taking this L and L dash are called endpoints of the lattice rectum. Other side also you are having some endpoints. See the explanation clearly. See here also endpoints are there. See here L. What is the value of L? AE comma b squared by a. See here L dash. What is this? AE comma minus b squared by a. From this we are able to compare the results. See here. This must be L1. What is the difference? Here AE positive. Here AE negative. Therefore it must be minus AE. Then b squared by a. So just think about the quadrant. It is first quadrant. Both are positive. It is second quadrant. X takes negative, Y takes positive. So see, minus AE comma b squared by a. Therefore L1 is minus AE comma b squared by a. Now see L1 dash. See this is which lies in the third quadrant. In third quadrant both X and Y must be negative. Therefore this must be minus AE comma minus b squared by a. So here L1 is AE comma minus AE comma minus b squared by a. So it lies in the first quadrant, it lies in the fourth quadrant, it lies in the second quadrant, it lies in the third quadrant. Depends upon the quadrant, we take the positive and the negative in your X and Y coordinates. So these students, no need to memory, just to recall what are the concept. When compared with the ellipse, the standard equation having only one difference. Just to recall, x squared by a squared plus y squared by b squared equal to what is the standard equation of the ellipse? For a hyperbola, it takes minus. Therefore, x squared by y squared minus y squared by b squared equal to what is the standard equation of the hyperbola? In standard equation, b squared equal to a squared of 1 minus e squared for an ellipse. Just a change. For a hyperbola, b squared equal to a squared of e squared minus 1. Then for an ellipse, from that only we are deriving, for an ellipse, the value of e equal to square root of a squared minus b squared divided by a squared. For a hyperbola, square root of a squared plus b squared. Just to comparatively study. Then you are able to recall everything. So these are the standard result. Center, then foci, vertices, directrices. Same result comparing with the ellipses. Both are same results only. But diagrammatic explanation, it has changes some. See here, L and L dash here. But ellipse, it goes to the other side. Then foci comes there. In comparatively study the diagrammatic explanation, it has some changes. But the results, the first four results are same. Then AA dash equal to 2A is called here. For a hyperbola, it is called transverse axis, length of the transverse axis. But for an ellipse, it is called length of the major. Then equation of major in your ellipse, here equation of transverse. Then BB dash equal to 2B is called length of the minor in your ellipse. Here it is nothing but the name is conjugate. Then equation of minor, here equation of conjugate. Then the other, length of the lattice rectum, equation of the lattice rectum are same. Then the endpoints of the lattice rectum are also same. So dear students, just to compare the standard results of ellipse and the standard result of hyperbola, you can get some ideas. Then draw the diagram. Diagram is something different. Just I can say, in between A and A dash, just now I explaining. In between A and A dash, ellipse should be placed. You can revise this. But the naming must be changes there. In your ellipse, here comes F. Here comes F dash for an ellipse. Center must be the same only. Here F and F dash. Instead of Z, F and H dash. Then take this is L and L dash for an ellipse. Here, small changes when comparing with the diagrammatic explanation. So you are able to listen the concept, then take down the observation. No need to memory anything. Just a comparative study. What is the difference between an ellipse and a hyperbola? Say the diagrammatic. If you are very thorough in diagrammatic explanation, then you can recall all the results from the diagram. Now we are discussing about type number 1 only. We have one more hyperbola. Very small changes. Type number 2. See here, this is type number 2. The equation is y squared by a squared minus x squared by b squared equal to 1. Transverse axis along y-axis. Transverse axis along y-axis. This is type number 2. See the difference. Type number 1 is x squared by a squared minus y squared by b squared. This is type number 1. Transverse axis, the type number 1, transverse axis along x-axis. Just now I explained what is the meaning of transverse axis. It is a penetrating axis. In between only the hyperbola exists. In the axis only hyperbola exists. So transverse axis along x-axis type number 1. Then transverse axis along y-axis is type number 2. See the difference here? It is starting with the x squared. See here, starting with the y squared. That is the only one change. X squared by a squared, y squared by b squared equal to 1. See, starting with the x squared. Then here starting with the y squared. That is the difference. But comparing with the ellipse, see the ellipse. X squared by a squared plus y squared by b squared equal to 1. A greater than b. This is type 1. Here major axis along x-axis. You are using the word major axis along x-axis. So this type of application, if you are having, then no need to memory. What is the difference here? X squared by a squared plus y squared by here positive, here negative. When comparing with the type 1. Now x squared by b squared plus y squared by a squared equal to 1. This is type number 2, a greater than b. Major axis along y-axis. Major axis along y-axis. Just comparatively you can observe the knowledge. See here the denominator changes. X squared by a squared. Here x squared by b squared. So always I am saying a greater than b. For both conditions a must be greater than. If greater value is the denominator of x, then that is type number 1. Here the greater value is denominator of y, type number 2 for an ellipse. See the difference here. X squared, starting with the x squared, it is type number 1. Transverse axis along x-axis. Starting with y squared. Here don't think about a squared b squared. So whatever may be the value, don't think about a squared b squared. Here think about x squared y squared. But here think about a squared b squared. That is the difference between an ellipse and hyperbola. Now we are going to take the results of type number 2 for a hyperbola. See, y squared by a squared minus x squared by b squared equal to 1. What is the name of this? Transverse axis. Just now I am explaining. Transverse means this is a penetrating axis. It is x-axis. X dash must be center C0, 0. Now this is called L. This is called L dash. L and L dash. Now, a hyperbola exists here. This is y-axis. This must be A. This must be Z. This must be F. In the same way, it must be Z dash. Now see here. Here A dash. Here Z dash. This is the diagrammatic explanation. See here, the hyperbola exists in y-axis. So this axis is called transverse axis. So this is called transverse axis. In type number 1, you are taking like this. See here, this is called a transverse axis. Now y-axis is called transverse. Therefore, we are saying that type number 2 is transverse axis along y-axis. So now we are going to write down some results now. It is x-axis, L, L dash. Now say the results. What is the name of center? The same only. Center is 0, 0. Center is 0, 0. It is denoted by C. Now see F. The same one. 0, AE. Because it lies in the y-axis. In type number 1, you are using AE, 0. Here 0, AE. Here, sorry, and it is F dash. F and F dash. Here only Z dash. Now 0, minus AE. Therefore center 0, 0. Now it is called vertices A. 0, A dash must be 0, minus A. Here Z must be 0, A by E. Here Z dash must be 0, minus A by E. Now you can say center is center C. This is result number 1. Number 2 result, foci F 0, AE, F dash 0, minus AE. This is the foci. Now result number 3, vertices. Result number 3, vertices A 0, A dash 0, minus A. Then directrices, equation of the directrices. Equation of the directrices is y equal to A by E here, negative A by E here. Therefore, we can say y equal to plus or minus A by E. This is the directrices. Y equal to plus or minus A. The same standard result when comparing with your ellipse also the same, because it lies in the y-axis. That's all. When compared with the type number 1, just changes the coordinates of x and y. 0, 0, no change. Here see type number 1, AE, 0, minus AE, 0. Just interchange the coordinates of x and y. See vertices in type number 1, A, 0, minus A, 0. Here you are using 0, A, 0, minus A. Then directrices. There you are using x equal to plus or minus A by E. Here they are using y equal to plus or minus A by E. Now, what is the fifth result you see here? A dash. Now A dash, that is 2A, is the, what is the name? A dash equal to 2A, length of the transverse axis. Use the word transverse. Transverse means it is a penetrating line, the axis. So it is called length of the transverse. A dash equal to 2A, length of transverse. Length of transverse. Then equation of transverse. Equation of transverse axis. What is the name of equation of transverse axis? See here, y-axis is the transverse axis. Its equation x equal to 0. Then BB dash equal to 2B. See here, what is the meaning of BB dash? I am just explaining. It is a supporting axis only. It is a supporting length. A dash can have some length, but BB dash is assumed. It is nothing but a supporting one only. This is called BB dash equal to 2B conjugate. Conjugate axis, length of conjugate axis, length of transverse, length of conjugate. Now, what is the equation of conjugate? Then equation of conjugate. Equation of conjugate is, see x-axis is here conjugate, its equation y equal to 0. Here x equal to 0, here y equal to 0. So length must be the same, a dash equal to 2a, length of the transverse. Then equation of the transverse axis, you have to listen, it is nothing but y-axis. Equation of y-axis, x equal to 0. Here length of the conjugate is bb dash equal to 2b, length of conjugate. Then equation of the conjugate is nothing but x-axis equation y equal to 0. Then length of the lattice rectum, that must be same for any type because it is the length. Length is the same only. So length of lattice rectum is the same result, 2b squared by a. Length of the lattice rectum, the same one, 2b squared by a. Then equation of lattice rectum. See, lattice rectum, what is the definition you are using? It is a focal chord perpendicular to the transverse axis. See here L and L dash. It is a focal chord perpendicular to the transverse axis. This is called, we are saying, this is L and L dash is called endpoints of the lattice rectum. Here also you are having same endpoints. But equation means y equal to plus or minus a by e. There you are using x equal to plus or minus e. Here you are using x equal to plus or minus ae, not a by e. Here 0 comma ae, here 0 comma minus ae. So y equal to plus or minus ae. This is the equation of lattice rectum. And also you are having endpoints. See the endpoints L and L dash. Here also you are having one more endpoints. Say L1, L1 dash. You are able to observe all these things. So dear students, go through all the theoretical concept. Then you have to listen and work out. Then no need to memory. Just to draw the diagram. From the diagrammatic explanation, you can just recall all the results. So try yourself. Thank you.